replacing Apache Hive, Elasticsearch, and PostgreSQL with Doris. So these are three very different databases. This one is mostly used for text search, for structured, SQL type database, and big data. Wow, I wonder how come they replaced with all this, or what we are going to find in this article. So this was released, not surprisingly, by the Apache Doris project itself. Okay, so let's see. How does a data science service company build its data warehouse? I worked as a real-time computing engineer for a due diligence platform, which is designed to allow users to search for company business data, financial. Okay, so we are talking here something like an analytical searching for business data, searching for financial, searching for legal details. Legal details might be also text search engine. It has collected information of over 300 million entities in more than 300 dimensions. Interesting. Big analytical database, not necessarily by the entities. So there could be many more rows. The duty of my colleagues and I is to ensure real-time updates of such data so we can provide up-to-date information for our registered users. Interesting. That's the customer-facing function of our data warehouse. Other than that, it needs to support our internal marketing and operation teams in ad hoc queries and user segmentation. Yes, this is typical of analytical databases, the requirements that we need from them. Lot of rows, lot of dimensions, lot of different customers that are using them, ad hoc query, whatever. Which is a new demand that emerged with our growing business. Our old data warehouse consisted of the most popular components at the time, including Apache Hive, MySQL, Elasticsearch, and PostgreSQL. Yes, this was the old time. Today, everything is around, most of the things are around like big storages and Spark and the like. And today there is also ClickHouse. But let's see. They support the data computing and data storage layers of our data warehouse. Data computing, Apache Hive serves as the computation engine. Okay. Data storage, MySQL provides data for Databank, Tableau, and our customer-facing applications. Elasticsearch and PostgreSQL serve our DMP user segmentation system. The former stores users profiling data, and the latter stores user group data packets. As you can imagine, a long and complicated data pipeline is a high maintenance and determinal to development efficiency. Moreover, they are not capable of ad hoc queries. So as an upgrade to our data warehouse, we replaced most of these components with Apache Doris, an open source MPP. What is MPP? Maybe multipurpose? Multipurpose. Yeah, sounds like something multipurpose, because this database is doing multipurpose things based analytics database. So so this is the before. On the before, we see that they had here the clients, sources writing. This is where their mail stack was. They had MySQL, Elasticsearch, Postgres. They have some scheduling. They had some applications like Tableau, customer facing. Okay. After, Doris is replacing MySQL, Elasticsearch, and Postgres. Interesting. Let's see what is this Doris. Data flow. This is lateral view of our data warehouse, from which you can see how the data flows. They have the sources, the MySQL, the logs, goes to Bing logs, user activity logs. Okay, so this is Kafka, flat tables orders, flat tables user activity. They have here like the streams inside Kafka. Here I see a small Flink SQL, Flink SQL. Everything goes to Apache Doris. Interesting. Apache Doris is serving here everything. They have here such a gateway service before the customer. So the customer facing apps like Tableau and DMP are accessing through a gateway service, the Doris. Let's see what Doris is. For start, in general, when we investigate a new database, we need to know how it stores the thing, what it's doing. Let me give a guess about this Doris. It would externalize how you store the things on files like S3, and then it would provide you mechanisms to run queries on top of the data. And extensible, like run Spark on top of the data. And it would also have built-in mechanism to run queries on top of the data, but I have a feeling that the data is going to be stored externally on files. Let's see. For starter, bin logs from MySQL will be ingested into Kafka via canal. Okay, so we are ingesting things to Kafka, while user activity logs will be transferred to Kafka via Apache Flume. In Kafka, data will be cleaned and organized into flat tables, which will later turned into aggregated tables. Then data will be passed from Kafka to Apache Doris, which serve as the storage and computing engine. So Doris will be both the storage and computing engine. How does it do its magic? Whenever there is magic, there is not really magic. We are trading off something. We adopt different data models. Okay, I get it. So Doris will adopt different data models and maybe be storing the data in multiple ways. We adopt different data models in Apache Doris for different scenarios. Data from MySQL will be arranged in the unique model. Logs data will be put in the duplicate model, while data in the AWS data warehouse layer will be merged into the aggregate model. This is how Apache Doris replaces the role of Hive, Elasticsearch, and PostgreSQL in our data warehouse. Such transformations has saved us a lot of effort in development and maintenance. It also made ad hoc queries possible and our user segmentation more efficient. Interesting. Ad hoc queries. Before, every time a new request was raised, we developed and tested the data model. So every time they had a new requirement, they developed a new data model in Hive and wrote the scheduling task in MySQL that our customer-facing application platform would read results from MySQL. It was a complicated process that took a lot of time and development work. After, since Apache Doris has all the itemized data, whenever it faced with a new request, it can simply pull the metadata and configure the query condition. Then it is ready for ad hoc queries. What does it mean, configure the query condition? I hate when there is this magic that is not clear. Then it is ready for ad hoc queries. In short, it only requires low-code configuration to respond to new request. So when you get a new request, you need to do something. It's not yet clear what something you need to do. And then you're presumably ready for ad hoc queries. But I'm sorry they didn't tell how it's working. They didn't describe how files are stored. They didn't describe the query engine. They didn't describe yet anything for me. User segmentation. After a user segmentation task was created based on metadata, the relevant user IDs would be written into the PostgreSQL profile list and the MySQL task list. Meanwhile, Elasticsearch would execute a query according to the task conditions. After the results are produced, it would update status in task list. Okay, this is not interesting. The Postgres, okay, of course you update task list and you have things to do, but what are you doing? The PostgreSQL plugin is capable of computing in the intersection. Okay, this is more interesting. So it could compute automatically intersection, union, and different of bitmaps. Then PostgreSQL would provide user groups backed in downstream operation platforms. Tables in Elasticsearch and PostgreSQL were unreusable, making this architecture cost inefficient. Plus, we had predefine the user tags before could execute a new type of query. This loading step. After, the user IDs will only be written into the MySQL task list. For first-time segmentation, Apache Doris will execute this ad hoc query based on task conditions. In subsequent segmentation task, Apache Doris will perform micro-batch rolling. This gives another hint. Micro-batch rolling. Okay, so there seems to be some optimization that it's doing. It sees the query and it's computing like rolling like multiple dimensions ahead of time and compute the difference set, and it can do union intersection set compared with previously produced. So there is another optimization, what was produced previously, and notify downstream platforms of the update. In this Doris-centered user segmentation process, we don't have to predefine new tags. Instead, tags can be auto-generated based on the task condition, the processing pipeline, and the flexibility. That's interesting because you see my problem with this. They don't describe how this actually works. They say there is this and that and this, but this is not a description. I mean, I don't understand how it's working after reading this. It seems like it's missing a lot of details. Tricks to speed up segmentation by 30%. Due to risk, how do you do the segmentation? How do you store the files? Okay, is it B-tree? What do you do there? Due to risk, version reasons, random generation of user ID is the choice for many companies, but that produces sparse and non-consecutive user IDs in the groups. Setter, okay. Step 1, create user ID mapping table. We adopt a unique model for user ID mapping table where the user ID is a unique key. Okay, so we adopted the unique ID user ID table key. Supposing that we need to pick, let's see if there is conclusion. Okay, so I'm sorry. Described in general that the only thing I take from this is that someone was able to replace Postgres with and Elasticsearch and Hive with Doris. That's the only thing I took from it. I'm not sure which use cases would it exactly support. Not from this article. Conclusion, we have two clusters in Apache Doris accommodating terabytes of data with almost 1 billion neurons flowing in every day. Okay, this gives some new indications. We used to witness a steep decline in data ingestion speed as data volume expanded, but after upgrading our data warehouse with Apache Doris, we increased the data efficiency. Yeah, but what did I lose? I mean, I for sure, whenever there is trade-off, I lose something. And I don't see here what I lost by this. Yeah, for sure. I mean, in PostgreSQL, you have all these complex SQLs that you can write. What did I lose? Did I lose some of this? Also, in user segmentation with result set, for sure, it's always a trade-off. I don't see the trade-off here. Also, in user segmentation with a result set of less than 5 million, it is able to respond within milliseconds. Most importantly, our data warehouse has been simpler, friendlier to developers. I think we need to, in order to really understand it, we need to go to the white paper of this. We need to understand how it's working behind the scenes, but what we take from this is that there is a tool, there is a database called Apache Doris, and someone was able to replace PostgreSQL, Elasticsearch, and Hive with this Doris.